Math 1, Practice 2.6.2. So now we're comparing exponential functions. And the main two things we're talking about are the y-intercept and the... now here we don't have a slope. We do have a rate of change, an average rate of change, but we always need an interval to help us figure that out. Okay? So we're going to have to do a few things here. We can't just... that slope isn't universal because of the way the exponentials, remember, they have that basic shape with that curvature with that asymptote. So once again, in a table, our y-intercept we find where x is 0 and where f of x or y is a number. Okay? That's how we find our y-intercept. On a graph, it's where it crosses the y-axis. Okay? On an equation, it's usually this format, a times b to the x. So it would be where a is. Okay, that's our y-intercept. And in a story problem, it's just where it's starting. Okay, where it begins. Now, for the rate of change, the way we find that is we need an interval. Like this is 2 to 8. So we'd have 2 to 8, we'd find that difference of 6, and then we'd have numbers here. So like 10 to 12, that difference would be 2. Okay, and it'd be 2 over 6. Okay. On the story problem, you find the 2 points. You go up, the y value, and the x. Okay, then y over x again. On the story problem, it's how it's growing. What are you multiplying by? Actually, not how what you're multiplying by. It's once again the intervals. You find those two differences. With the equation, you have to the b is what you're timesing by, it's not the rate of change. You'd have to plug in 2 for x, figure out what that is, plug in 8 for x, figure out what that is, and use that to give you your information. So it's a little bit more work. Well, let's get going on this. So number 1. So which function has a greater rate of change over the interval 2 to 8? So we're going from 2 down to 8. So grows by 6. And then we've got 2086, so I go 2086.82 minus the 15,046.92, and it gives me 539.9. So 539.9 over 6 gives me 89.983 repeated. Okay, so that's its rate of change. Now for the function we do the same thing. So the interval of 2 is right up there at about 1400. 8, which is nearly at 1800. We'll just estimate up there at 1800. So same distance of 6, that's our x. Change in y here, we go 1800 minus 1400, which is 400. So 400 divided by 6, which gives us 66.6 repeated. So obviously function A has the higher rate of change. It's growing quicker than function B. But now we check the y-intercepts. So where is x 0? So we have a y-intercept of 1400 on function A. Function B looks like it's halfway between, so it'd be 1300. So B also has a lower y-intercept. Okay? Alright, number 2, now we're given 2 equations. So it says, what function has a greater rate of change over the interval 0 to 5? So the x value from 0 to 5 has a difference of 5. Okay. What about the y values? So to do that, we plug them in. So I go f of 0 equals 1/2 to the 0. Anything to the 0 power ends up being 1. So it's 1. Then I do f of 5. So I'd go 1/2 to the 5th. Okay, and when you do powers to fractions, it's like 1 to the 5th, which is 1, and then 2 to the 5th, which is 2 times 2 times 2 times 2 times 2. So that would be 4. That would be 8, 16, 32. So it would be 1 over 32. Okay, so I go 1 over 32 minus 1 to get my y value change. Okay, so the change in x is 5, change in y would be 1 over 32 minus 1. Now, to get the same denominator, isn't 1 the same as 32 over 32? So same denominator. So then 1 minus 32 would give us a negative 31 over 32. Which negative 31 divided by 32 is negative 0.96875. Divide that by 5. And we get a rate of change of, let's write that up here. So it would be a rate of change of negative 0.19375. Okay. Then to find the y-intercept, make the x 0, which we did right there, and we found out that that became 1. So our y-intercept is 1. Function b, same idea. So g of x, or g of 0, equals 2 to the 0. That would be our y-intercept as well as the start of our y values. So that would be 1 as well. So they have the same y-intercept, don't they? Y-intercepts of 1. Okay. The x is still 5. The change in the x's is 5. The change in the y would be, then we go 2 to the 5th. Well, 2 to the 5th we found out was 32, didn't we? So we'd go 32 minus 1, which would be 31 for y, so 5 over 31 would be our rate of change, which is 0.1613 if we round. Okay, so this one's negative, so it's decreasing, but it's decreasing at a slightly faster rate than this one, which is increasing. Alright, number 3. Now we've got a formula and a table. So let's do the table first. Y-intercept, easy peasy, right? X is 0, y is 350. Okay, the rate of change from 2 to 8, so 2 to 8, that's a 6. So 587.88 minus 398.45 gives us 189.43. So 189.43 over 6, or divided by 6, gives us 31.57. We round. Okay, function A, starting point, it's this number out here. That's going to be our y-intercept. So equals 400. Okay, our rate of change. Now we're going to have to use a calculator, type this in, put 2 in for x, 8 in for x. So I'll just do that on a calculator. So f of 2 would equal, so I go 400 times 1 plus 0.06 divided by 12. Raise that to the 12 times 2. And I get 450.86. Then we do f of 8. Okay. So I type that whole thing in, but instead of 12 times 2, it's 12 times 8. That gives me 645.66. Now I take this, subtract that, and that gives me 194.8. Because it's 6 away, I go 194.8 divided by 6, and we get 32.47. So, function A has a bigger y-intercept and grows at a faster rate than function B. Okay, they're both growing, but function A would be the one you'd want to choose over function B. Unless you wanted it to grow slowly, then I suppose you would choose that one. Okay, number 4. Compare the properties of each function over the interval 0 to 8. Okay, so y-intercept, a times b to the x, so 3, so y-intercept of 3. Function b, y-intercept of almost 0. That 0 would be the asymptote, so it's right above. So I would say our y-intercept equals like 0.1. You probably could write 0 if you really wanted to, but we technically shouldn't. Okay, but for figuring out like this, it's basically 0. So 0 to 5, 5 would be right about there. Okay, So we go up about 500 and over 5. So for the rate of change, it would be 500 over 5, or 100. Okay, for 4, that y-intercept we know is 3 already. That's where the x is 0, right? So at 5, we'd go 3 times 2 to the 5th. 2 to the 5th we know is 32, times 3 is 96. So difference here is plus 5, difference here is plus 93. So 93 divided by 5 gives us a rate of change of, see, 93 over 5 equals 18.6. So function B grows a lot quicker, even though it starts a lot smaller. Okay, then function A. Alright, number 5. So these just take a while because they're not as simple as the linear, are they? Interval 0 to 10. So at 0, your y-intercept, function B, you're at 800. Okay, we're going clear to 10, which is right here. That looks basically 475. So from 800 down to 475, so 800 minus 475, we went down negative 325, and to the right 10. So for the rate of change, it would be negative 325 over 10, which would be negative 32.5. Okay. Now function A says a fully inflated beach ball is losing 7.5% of its air every day. The beach ball originally contained 800 cubic inches of air. So our y-intercept is 800. So they have the same y-intercept, don't they? Okay, and they're doing the same process, so let's see what about the rate of change. Now this one says that we're losing 7.5%, so we need to make a table from 0, 800, down to 10. Okay, and we're timesing it by 0.075 each time. So I could just type that in my calculator, or I could make a formula and go y equals 800, my starting point, times my rate, 0.075, to the x. And then instead of x, put 10. And that would be an easier way. So 0.075, so I turn it into an equation to help me out. To the 10th plus 800. Okay. That didn't really help me out because it's basically saying it's still 800. So my rate of change must be very small, but for average rate of change I need to find that value. So 800 times 0.075. Okay. Oh, we probably need to think about this differently, don't we? So it's losing 7.5%, but it still has in it 100 minus 7.5, so it's still got 92.5%. So that's actually we want to multiply by 92.5. That's why my equation didn't work. Should have been 800 times 0.925 to the x, or to the 10th. That's better. That would be 366.87. So 366.87 minus 800 gives us negative 433.13. So obviously function A is losing it a lot quicker than function B, even though they have the same y-intercepts. Okay, number 6. Compare the properties over the interval 0-5. Jasmine received a job offer with a starting salary of 32. There's our y-intercept. Okay, that's also the number if we made a table for 0. Okay, and a 1.5% increase every year. So every year she makes her 32,000, which is 100%, plus the 1.5%, so 101.5. So we times by 1.015. So 32,000 times by 1.015. So in year 2, she would have made $32,480. Year 3, $32,967.2. Year 4, $33,461.71. And in year 5, $33,963.63. So we're adding 5 here. We are adding, subtract 32,000. We are adding 1963.63. So Y-intercept 32,000, rate of change was that 1963.63 over 5, which gives us about 392.73. So every year she's making about $392 more, according to this average rate of change. So function B, a second job offer for Jasmine can be described by the function f of x equals 30,000 times 1 plus 0.02 to the x. 30,000 is her starting salary, same as that one, so that's our y-intercept. Then just like how we took 100% and times it by 1.5, she takes 100% and adds 2%, so basically 102%. So she's making a slightly better raise. So if we made a table of this one, 0 would be 30,000. We need to get to 5, so plus 5 here. And so we take 30,000 times by 1.02. So after year 1, she'd have 30,600 times by 1.02. Then year 3, 31,212. Year 4, 31,836.24. And year 5, she'd have 32,472.96. So I take that, subtract the 30,000 from it, and that gives me 2472.96. Okay, which we divide that by 5, and we get our rate of change of 494.59. So from the looks of it, you'd probably be better off taking the second one because you're growing at a faster rate, which means you'll get more money sooner. Alright, 7. So, interval 0 to 4. 0 to 4 plus 4, 0 to 4, 1789 minus 1900, negative 11d1. So y-intercept, I keep putting the equals next to my y, don't I? Is 1900, right? Because that's where our 0 is. Then rate of change would be negative 11d1 divided by 4, and we'd get negative 27.75. Okay, so the enrollment is we are losing 27, basically 28 students every year. Okay, so now let's look at function A. So y-intercept 1700. Okay, rate of change is right there. So we need to figure out at 0, it was 1700. We need to get to 4. Okay, so I put 4 in for x, so 1700 times 1 plus 0.025 to the 4th would give me, oh, messed up. I put 17, not 1700. Makes a big difference. So we get 1876.48. Looks like they were rounding, so if we round, let's just leave it like that and round later. So we've got the 4 here again, but the difference here is 176.48. So 176.48 divided by 4 will give us a rate of change of 44.12. So they're basically adding 44 students, their rate of change, because they're growing, whereas the other high school is falling at the negative. Okay. All right, number 8, almost done here. Interval of 0 to 3. So at 0, that's your y-intercept, so it's right there. So that would probably be 38. And the interval is from 1, which would be right there, to 3, which is right here. So that would probably be 44. And that would probably be 40. So going up, we'd add 4. To the right, we add 1 to 3 is 2. So the rate would be 4 over 2, which is just 2. So rate of change here is 2. So every year, the value goes up by $2. The y-intercept, when you started looking at the value, it was at probably $38. Okay, so let's compare that to the other one. So y-intercept of 52. So it starts with more money. It's worth more money to begin with. But let's see that rate of change. Okay, from 1 to 3. So that's plus 2. This is plus 58.49 minus 54.08, 4.41. So 4.41 divided by 2 gives us 2.21. So it's growing by $2.21. So more expensive, and every year growing more. So hopefully you have stamp A, not stamp B. Alright, number 9 and 10. Let's finish these guys out. Seems like this one took a lot longer than it should have. Alright, so interval 0 to 4. So adding 4 here. 12,280.33 minus 22,450 means it's a negative 10,169.67. So our rate of change would be this divided by 4, which would be a negative 2,542.42. Okay, this is dealing with the value of cars, which they do go down. So the y-intercept would represent how much you paid for it. So car A, you paid $22,450. After 4 years, it was worth $12,000. So every year, you basically lost $2,500. Okay, so let's see if B is different. Okay, so y-intercept right there. So you paid less for it to begin with, right? So 19,375. Now we need to figure out basically a table, just like we did here. So at 0, it was 19,375. Using 4 in that x, we put that into our calculator. So 19,375 times 1 minus 0.16 to the 4th gives us 9,646. So it was cheaper to begin with, be cheaper to sell. But we take that and we subtract 9,646.26 minus 19,375. We get negative 9,728.74. Divide that by 4. And we get our rate of change of negative 24,332.19. So every year you're losing less money on car B, but it's still worth less because you paid less to begin with. So you'd have to decide which one was better on that. Okay, now number 10, from the interval 0 to 10. So y-intercept here is 1,000. That's easy enough, right? We like the graphs for that reason. Okay, the rate of change 10 is right here. So we probably call that right about there, about 1350. So we go up. 1,000 to 1350 would be 350. To the right, 10. So our rate of change would be 350 over 10, or 35. So every year, we're earning about $35. Okay. All right, now function A. We invest 1,000. Okay, so that's our y-intercept. Is 1,000. and its interest rate is 3.75% compounded monthly. So basically, every month, we're taking that and timesing it by that plus the 100%, so it would be 1.0375. But that's months, so we'd have to get to 12 months for 1 year. So we want to get clear to 10 years, which would be 120 months. Now that's going to suck if we go that far, isn't it? Okay? So what we want to do is we want to create a formula here. So it would be 1,000 times 1.0375 to the x. So we make that to 120, and we can find that value there. So we use the calculator and do that. So we get 82,903. Actually, that doesn't seem right to me. I think because of it being compounded monthly, we have to use a special formula. Let me write it down. So this is what we have. P stands for the principal. That's your Y-intercept. So we started out with 1,000 times 1 plus our rate was 0.0375. This 1 stands for the 100 right there. Okay. Over N stands for how many times it's compounded a year. So monthly would be 12 times per year. Times 12 times the time. The time was 10 years. Okay. So what we did wrong was we're forgetting that compounded monthly changes our fraction. Okay, so I typed that in. So 1,000 times 1 plus 0.0375 divided by 12 to the 12 times 10, or 120. That gives me, that's better. That gives me for 10 years 1,454.14. So to find our rate of change, this would be plus 454.14, and this would be 10 because we did it for 10 years. So 454.14 divided by 10 would give us 45.41. So we'd be earning, for every year, we'd earn basically $45. Okay? So I'd probably go with A instead of B because you would end up making slightly more money. And over time, even more. Alright guys, so there we go for those ones. Hopefully it wasn't too bad for you, but there we go.